How do creatures track all kinds of environments? What innate features enable them to adjust? In the second part of Continuous Environmental Tracking, or CET, we'll reveal more of this groundbreaking model of adaptation that God engineered into creatures. These abilities detect changes in myriads of external conditions and make suitable self-adjustments. Coming up on today's edition of Origins, Creation Engineering Part 2 with Dr. Randy Guliuzza. Hello and welcome to Origins. I'm Ray Heiple, and it's an honor to be your host today. During this program, we showcase interesting guests who present evidence from science along with other important facts, validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. Randy Guliuzza, has undergraduate degrees in engineering and theology. He has earned an MD and also a Master of Public Health from Harvard University. Dr. Guliuzza is a registered professional engineer. In 2008, he retired as Lieutenant Colonel from the U.S. Air Force. Now he's the president of the Institute for Creation Research in Dallas, Texas. Welcome to the program, Dr. Guliuzza.
Thank you, Ray.
This is part 2 of a 2-part program, and in the first part, we began to look at CET, Continuous Environmental Tracking. Can you remind us what that is?
Oh yes, I'd love to. Continuous environmental tracking is actually an engineering-based approach to explain how organisms adapt, as Paul Nelson says right here, doing it as if Darwin had not been born. We're doing biology in a way, a completely different way. We're going back to a Bible-based approach where we see, and as we discussed last time from Romans chapter 1, verse 20, we see the evidences of engineering inside of these creatures. And what we're actually looking there is that phrase that says they're understood by the things that have made, as we discussed last time, that word made could actually be translated as workmanship. So we're seeing evidences of workmanship, and workmanship is engineering based. And so we're going back and we're treating organisms as if they really were designed. It showcases the wisdom and the genius of the Lord Jesus Christ, how He put these things together and He understands how they operate. And then we backed up a little bit and we found out that Darwin, when he started his theory of origin of the species, wasn't really trying to explain the diversity of life. He's trying to explain the 900-pound gorilla in the room is, why do creatures look so highly engineered but without appealing to the ultimate engineer, the Lord Jesus Christ, in explaining all of those things? And he came about with an externalistic approach. But we flipped that 180 degrees and we came up with a way of explaining organisms and how they adapt from an engineered-based approach, an internalistic-based approach. And as you mentioned, it's called continuous environmental tracking. And there were a couple key distinctives about it. One is that CET is an organism-focused approach. In other words, we're not looking at the environment. We're looking inside of them. We're looking for highly regulated systems, control systems, that enable them to change. So that is a completely different approach than Darwin had. He looks at the environment. We're looking at the creatures. We're going to be using engineering principles to explain biological functions. In other words, in this particular case, the biological function is adaptation. So the same engineering principles which enable this car to go up and down hills and maintain its speed, in other words, adjust itself, are going to explain how organisms adapt. In other words, we're looking for sensors in creatures. We're looking for logic that says, if something changed, then I want to produce an appropriate response. And we're looking for output responses from them. And therefore, we're able to look for corresponding system elements. We see a man-made adjustable car, and then we look at creatures that can adjust themselves to changes in environment, we're looking for corresponding elements between those two. We're looking for solutions that actually precede the challenges and are not due to the challenges, but precede the challenges.
Do we have other examples? You know, the critic might say, well, you guys have shown this one example here, but what else can we show, or what are some of the other things that will back up this CET approach?
Yes, we have some other examples there, and I'm going to talk about those. And so if you don't mind, I'd like to go to the board here and talk about them.
Let's do it.
So now, as we're looking at these different examples, we see from the scientific literature that adaptation isn't characterized at all like Darwin was thinking, as slow and gradual, but it's really characterized as highly regulated, very rapid, sometimes repeatable and reversible, and with responses that are so targeted, they're actually predictable. And I want to cover a few examples, since you requested, of looking at how organisms sometimes converge on the same responses to similar conditions. And there's an excellent illustration here as we look through it of CET, that if organisms have sensors and if they have the same internal logic that they're programmed with, then we should expect similar responses. In other words, if organisms are able to detect similar conditions and their logic inside is very similar, then we will see those similar responses. Let me give you a quick example. Caves, what a challenging environment that is. What happens if creatures suddenly find themselves trapped in a cave? Well, the organisms were meant to fill the earth, and that would include caves. So the designer, the engineer of the Lord Jesus Christ, probably built within them similar programming. And this is exactly what we find. We can look and we can see organisms that when they find themselves suddenly trapped in caves, they lose their eyes. We can see that their pigmentation changes. They go from a highly pigmented creature to a hypopigmented creature, or in other words, one that's almost an albino. And they change their circadian rhythms. At the same time, as you would probably expect, they augment other senses, their mechanosensation, their sense of smell, and all of those things. And we're quite familiar that one creature that does this is the blind cave fish. In other words, there's these surface fish, and when it's trapped in a cave, we find an albino, pinkish-looking fish without eyes. Evolutionists say they did that over anywhere from 8 million to 20,000 years ago, but we have evidence that they can actually make these changes quite rapidly. Remarkably, though, it's not just surface fish and cave fish. Salamanders, crustaceans, and even insects respond in the same way. So if we're going to study these creatures from an engineering-based approach, we're going to look for those internal changes that enable to do that.
So the difference being, the evolutionists would say the cave actually over time and over different, random chance mutations, these creatures were produced by the cave. And we're saying no, what you actually find is when you study the creature itself has the ability in itself over a much shorter period of time to respond to its environment in such a way that it maximizes those things that give it an advantage in the cave, and then it minimizes those things that it doesn't need for the cave.
Exactly. Perfect summary. That's exactly what we would find, and that's exactly what we would expect an engineer to do. Here's another cool creature. Everybody can see the beetle on the left, and you can see this ant on the right, but that isn't an ant. This is a rove beetle, and it lives in an environment with army ants, and army ants usually would attack this, but incredibly, this beetle, when it detects it's in the presence of these army ants, can actually change its shape to look like an army ant. So here's an army ant, here's the beetle, the coloration is the same, the behavior is the same, they even smell the same. In fact, the army ants, rather than eating this beetle, welcome it into its hive. It takes care of its brood, but not in a such beneficial way for the ants, because it's like 2 for you, but 1 for me. And it lives inside there because it can morph into looking like the army ants. In fact, it has been documented that it can morph into the shape of at least 9 different types of army ants along the way. And the researchers, you'll find this interesting, they write in this paper that they propose that the beetles were, quote, poised to look like ants, myrmecophily, and this ant-like adaptation. And they add that this near clade-wide pre-adaptive ground plan may underlie the repeated ant mimicry. Now, Ray, when was evolution ever supposed to have a pre-adaptive ground plan?
Yeah, it looks like they're borrowing a terminology from creationists and the idea that there is a design, there is intelligence, there is something in the creature already, but really their theory doesn't allow for that.
No, it doesn't allow for that. Here's another cool creature. It's called a stick spider. And these researchers are suffering for science in Hawaii as they study these spiders right here. And what we're looking at is one morphology. It's a gold morphology, and this spider lives on leaves. But there's another one that's kind of brown that lives on tree trunks, and a white one that lives on lichens. And what these researchers found was that when one of these spiders moves to another island in the Hawaiian chains, that it can actually morph or change into the brown form or the white form before the brown ones and the white ones from this current island actually get to the new island.
Wow, so all of the ability to do that was already in that spider. It didn't need to randomly develop this over generations of time as the ones that couldn't do it died out and the other ones did. It was already there.
All right, and I love how you're highlighting how really foolish that whole thinking is, that you're going to get these random genetic mutations and that some of them are just going to fortuitously solve problems, and then nature in some personified form is going to select for some or select against another or favor some or favor them not. You see, that's almost a magical, whimsical explanation where nature has given this a power and ability to somehow work and craft creatures. Totally wrong. As you've already summarized, these creatures have this ability up front, and they're able to rapidly adjust to these different conditions. In fact, this is what these researchers say. We usually don't expect evolution to be predictable. Actually, what they're talking about is adaptation. But we don't expect it to be predictable at all. It's supposed to be what? Random. But Hawaiian stick spiders of the Aramnus genus have repeatedly evolved. Actually, they've repeatedly adapted the same distinctive forms known as ecomorphs on different islands. They do it the same over and over again. So when you see that, you should be looking inside for some kind of design condition. They add this, you'll find this interesting, the spiders, quote, arrive on an island and boom, you get independent evolution to the same set of forms, this sort of rapid and repeated evolution. Ray, when was evolution ever supposed to go boom?
Yeah. You know, it's they're trying to be creative and clever. And on the one hand, we can be thankful that they're accurately stating what's happening in the sense of, sure, this is happening quick, but then they want to plug in their evolution and say, wow, this is so unusual. And actually, it's because that's not what you're seeing. Well, you know, they're so close. If we could just get them to say, wow, this creature already has this. That's why it's repeatable. That's why it always happens. It's in the creature.
It is in the creature. And that's why they go boom.
Boom.
That's why they go boom.
Abracadabra.
That's, well, yeah, and from their perspective, it is almost abracadabra because you're hoping for beneficial mutations and they're hoping that they solve a problem and they're hoping that they get favored by nature. You know, a much more rational and reasonable approach is to assume that these creatures have this ability, it's inside of them, and let's take our research time and start digging in the creature and looking for these highly regulated systems.
You know, that's an important point. It's not just that, okay, they're wrong in the way they're describing it. Science could do so much more if it actually began with the way things really are and then advanced from there rather than trying to just manufacture evolution into these changes. We're sort of stunting the progress that we could have.
Exactly. We are stunting the progress and we're not doing the research that we should. In fact, They even asked this question. We can ask whether there might be an underlying mechanism that leads to similar patterns of predictably repeated evolution in the course of adaptive radiation. Of course we should be asking that. We should be looking for these underlying mechanisms on all of them. And then they add that the Aramnis spiders have some sort of pre-programmed switch in their DNA that can be quickly turned on to allow them to evolve rapidly. How about adapt? Or better yet, self-adjust rapidly into these successful forms. But how that process might work is still unclear. Let me give them a suggestion. Let's start looking at these creatures for sensors that are specific for these changes. Let's start looking in them for the logic which can throw these pre-programmed switches on their DNA, and let's start looking for specific responses. Let's treat these creatures as if they were really engineered, and that's a great way of approaching change.
You know, Dr. Guliuzza, that loaded word, pre-programmed, something isn't programmed without a programmer. They're seeing it, they have to say it, and at the same time they have to try to explain it away by talking about evolving rapidly. I have to stop us right here, unfortunately. We need to take a break, but we will be right back. Stay with us for more right after this.
We hope you're enjoying Origins TV. It all started at Cornerstone Television in Pittsburgh, Pennsylvania. We've been producing new episodes for over 37 years now. We praise God for the success of the program and are excited to introduce you to Origins and to us. If you're interested in watching more episodes of Origins, you can find them on our YouTube page. Simply go to YouTube and search Cornerstone Television Network. Click the like and subscribe buttons, then you'll find the best episodes of Origins in our playlist. You can also visit our website at ctvn.org/origins. One more way you can stay connected with us is to subscribe to our free monthly Hope Today newsletter, which you can do from our website. And if you have any questions, call us here at Cornerstone Television at 888-665-4483. We'd love to connect with you. Thank you for watching.
Welcome back to Origins. We're talking to Dr. Randy Guliuzza, who's been sharing about creation engineering, part 2. Randy, we went to the break talking about spiders, and using the words of the evolutionists, they seem to have a pre-programmed switch. What does that mean? What does that lead us to?
Well, one thing it says is probably not random at all, and that the organisms have these solutions to the problems, in other words, to fit in the different tree environments that they're living in, and therefore we should be looking at creatures in themselves for these kind of mechanisms which enable them to rapidly adapt. So if we can switch gears a little bit from spiders over to mice, what we're looking at here is a gal named Hopi Hoekstra. She's a professor at Harvard University, and she's one of the leading researchers of mice. And she's made an interesting discovery. She found that mice that live in the prairies have short tails, but when they travel and they start to live in forests, they end up with longer tails. And I've never even seen a mouse living in trees or living in the forest with a longer tail, but she's discovered this, and she found that when they go from the Midwest to either forests on the East Coast or the West Coast, that they actually have a longer tail. And I just put the picture up there on the screen so that people can see that. You see west and east and prairie and forest. Sure enough, the mice that are living in the forest have these longer tails. And they conclude, and I tried to summarize what they're saying here in a shorter quote for them, that from a short-tailed prairie-dwelling ancestor, now that's a tongue twister, for geographically distant populations that arose across North America, longer tails have, here it goes again, evolved repeatedly in similar forested habitat. But we would say they've adapted. They've self-adjusted repeatedly to these similar forested habitats. And this is what's important. Variation in these traits is controlled by separate genetic loci. That means different genes, suggesting that this is not a random process, but implicating similar mechanisms of tail elongation in eastern-western populations. The two genetic genes we're talking about is the number of vertebrae increase and the length of the vertebrae increase, and they do this repeatedly over and over again.
What an admission that is, that they're not saying that it's the environment that's randomly causing this over a long period of time, but it's in the DNA. I mean, they admit that it's already there, and yet it's pointless to be there unless the environment provoked it, right? If their theory is right, but if what God has done is right, well, we would expect God to give it a variety of abilities to continue to live and function and respond.
Exactly, because the Bible tells us right at the beginning that He commanded creatures to be fruitful, multiply, and fill the earth. What a wonderful insight that is. That means these mice can fill prairie environments, they can fill forest environments, and I don't know exactly what the longer tail does for them, but it serves a purpose, and they're able to do that. I'd like to close with just two more quick examples. These are dealing with lizards. And this was an interesting case down in Brazil. There was a river and they put a dam in it and it made a lake and rapidly flooded the area and creating all these little separate islands. And before they had the islands, there were living in that area some large lizards and some small lizards. And the large lizards were able to eat the termites. And the small lizards could never get termites to eat. But interestingly, after they made the dam and flooded this, creating these separate populations, the large lizards went extinct. And suddenly the small lizards could eat the termites, but they're large. And interestingly, on all of the islands, the head of the small lizards got bigger so that it could eat the termites. And it did it predictably on all of the islands there. And in fact, this little graph on the left shows head length to body length for two different populations, mainland populations and island populations. And these folks said that this provided, quote, strong evidence that the traits can change what? Predictably and precisely in ecological communities, and illustrates that populations can respond both rapidly and in parallel to ecological changes. And I mentioned to you earlier that the literature is saying that adaptation is being characterized as highly regulated and rapid and repeatable and predictable, and this is exactly what we're seeing.
And that's a really good point, and we haven't really expanded on that. But when you think of the possibilities, let's just assume that the evolutionists are right for a moment, that things just change randomly, just according to mutation and time and what works and what doesn't work. Why would it always be that the lizard's head gets bigger? Why not have its stomach evolved so that it could eat plants? Or, a million other things. And yet every time it's always the head gets bigger. And that's, when you think about it, that is such a specific sort of thing that it would do it again and again and again if it was random. Maybe the lizard gets wings and it can fly and eat butterflies now. I mean, randomness would allow for all sorts of things to enable that creature to survive. But genetics would say, its head's going to get bigger. Yeah. And we can predict it, and it happens every time.
That's exactly right, and it's very specific to the need. And then finally, just close with one other lizard. What we're looking at is a man named Jonathan Losos. He's probably the world's leading researcher on these common lizards that we see everywhere. They're called anolis lizards. And he's researching in the Caribbean. And he researches all over islands, and he found that on islands with large trees, the lizards have long legs, and on islands with like scrub brush, they have short legs. Well, a natural experiment happened. A hurricane came through and killed all of the lizards on 7 islands. And they all had scrub brush vegetation. So he did an interesting experiment. He went to islands that had trees and he took lizards with long legs and he repopulated the islands with the scrub brush vegetation. And this is what he says. Our prediction, well, there again, they shouldn't be able to predict anything. It should be random. Our prediction was that they would evolve, how about adapt, shorter legs. Look, and they did over the course of 4 million years. No, over the course of 4 years, average limb length steadily declined on all 7 islands, exactly as predicted. All 7 islands were evolving. How about all 7 islands, the organisms were self-adjusting in lockstep with specific changes to the specific conditions.
How blind do you have to be to not see that the creature has this ability and it's going to do it every time? Because if it was random, again, maybe it turns into a snake and slithers or does something else. So many possibilities, and yet it's always the shorter leg. Come on.
I know, it's exactly there. So what we're really looking at in so many ways is a type of engineered adaptability where these organisms are able to continuously track environmental changes with responses that can be predictable and precise to solve problems, doing exactly what the Lord told them to do: be fruitful, multiply, and fill the earth.
What a powerful presentation you've made today, Dr. Guliuzza. I hope you'll be able to join us again soon.
Oh, I'd love it.
Well, we're out of time, and I want to summarize that what we talked about today was that scientists are seeing and affirming the inherent adaptability of a variety of creatures when they are placed in different external circumstances. They use words like pre-programmed, predictability, and pre-adaptive to describe what is happening, but then incredibly they attribute it to random, mindless evolution rather than the purposeful engineering that it clearly is. It just goes to show you that once again, we know what the Bible says is true, and the proof, it's all around you. If you enjoy Origins, we sure could use your help to keep this Creation Television program on the air. Your support, both prayerfully and financially, makes a big impact, and so let's work together to reveal how awesome our Creator really is. And we'll see you next time.
Thank you for watching this edition of Origins. For a DVD of this series, you can order online or send a $12 donation to cover shipping and handling and write to Origins Program number 2207, Cornerstone Network, Wall, Pennsylvania, 15148.
This presentation was made possible by the faithful prayers and financial support of you, our Cornerstone family.